Welcome back, everyone, to part 3 of our interview with Chris Richards from Pro-Am Racing. Hi, Chris.
Hi.
So, we have another online question here, Chris.
Okay.
It reads, why does my car surge when the engine is cold or hot?
Okay. That can happen for several reasons. The most common would be too lean an air-to-fuel ratio will make an engine surge. It could be an improper throttle position sensor setting. You're going to read on the forums an awful lot that your TPS should be adjusted at 0.98 at idle. I like to keep it a little less than that. 0.98 is awful close to the threshold where the Ford computer considers your throttle to be off idle, to be part throttle. If you set it at 0.98, mechanically your throttle body and your TPS don't always return to exactly the same spot. So sometimes you might be a little over 0.98, sometimes you might be a little under 0.98. You're basically going to confuse the processor and cause a surge problem. I like to keep the voltage down at 0.90, maybe even a little less. You're going to get much better results doing that. The other thing, if we're talking about an aftermarket management system, you control idle speed with either an IAC, or you should be controlling it with both, with an IAC and with Spark Advance. So if you had your gains too high for either one of those things, the computer can chase its tail. If the gains are too low, the computer can't react quickly enough. Some management systems don't control Spark Advance at all. I would say that if your management system is not controlling Spark Advance, you don't have a chance of properly controlling idle speed. Engines react to changes in idle speed much quicker than changes in airflow. An IAC is something that you use to maybe compensate for the drag created by an air conditioning compressor or a cooling fan dragging on the alternator. That's what an IAC is for. Stalling and surging, those are things that should be controlled with Spark Advance. And again, if your management system isn't controlling Spark Advance, you don't stand a chance. Throw that thing in the trash can.
Great, that's perfect. Chris, we have another online question.
Okay.
What is the maximum unscaled airflow the Pro-Am ECU is capable of calculating?
Okay. It's not really a calculation, it's a measurement. The mass airflow meter is going to supply that value to the processor. The processor can accept whatever value you want. There's no limitation, not in our processor. I understand where that question comes from. There's a lot of OEM processors and even aftermarket tuning software packages for those processors that put a limit on the amount or the number that you can put in for the airflow value. But we don't have a limit. You can do whatever you want.
Good, great. Chris, could you answer for us? What's the difference between a 9-point and 30-point transfer function?
Okay, so it's 9 points of flow on a transfer function sheet versus 30 points of flow on a transfer function sheet. 9 points are nice. 30 points are better if you're tuning. If you're going to do a tune, you really should be entering the transfer function into that tune, and the more points you have, the more accurate that transfer function is.
Great. Chris, can you explain self-tuning and what are the shortcomings for us?
Okay. Really, self-tuning has been around since the infancy of EFI. In the OEM world, self-tuning is called long and short-term fuel trims. The difference is that the OEM recognizes the need to limit the self-tuning capabilities of the ECU to a reasonable level. Otherwise, the system could self-tune itself right out of the ballpark. So these self-tuning ECUs, they simply take that to a whole new level. They use a wideband O2 sensor, and they take that reading from the wideband to trim the air-to-fuel ratio wherever it needs to be. But they take it to a level that really shouldn't be allowed. O2 sensors are very, very easily fooled. Minor ignition problems, exhaust leaks, a slight misfire will fool an O2 sensor. Certainly an engine with an aggressive camshaft can easily fool an O2 sensor. Honestly, an engine with a very aggressive cam isn't even a candidate for a speed density system, never mind a self-tuning speed density system. So anyway, anytime you have anything that would fool an O2 sensor, you're basically allowing the O2 sensor to dictate the air-to-fuel ratio to the processor, it can go way off in left field. We use O2 sensors as well. We use wideband O2 sensors as well, but we use them for what they should be used for, to make minor corrections to a calibration that is already properly written. And in fact, you could not use O2 sensors with our system at all. The calibration is done properly. Most people wouldn't even know the difference if we didn't even supply O2 sensors.
Wow. Okay, great. So, in closing, Chris, I have to ask, why don't we see more comments on the forums about your engine management system? We see an awful lot about your competitors' products.
Okay. Well, I think when you don't give people much to complain about, they tend not to complain. Since most of what you read on the forums is people trying to figure out what's wrong with their engines, you won't see us mentioned very often.
That's really good news.
Thanks.
Great. This concludes our interview with Chris Richards from Pro-M Racing. Chris, thank you for your hospitality and welcoming us out to your workshop today.
You're welcome. Thank you.
I hope everyone has found this very informative. And in closing, thank you so much, Chris.
You're welcome. Thanks.
Thank you. Hey, by the way, Chris, my Honda has a surging issue.
You've got a problem.